the balance of the lottery, because we should get all of the lottery winnings here. Okay, so this is a long test, but this is probably the most important test. Let's make sure this is doing what we want it to do. So we'll do brownie test-k. Test can pick winner correctly. Let's see if this works. Whoops, I forgot to put some parentheses here, some parentheses here. Let's try this again. And perfect. We are actually updating, paying out, and running our lottery correctly and fairly with true randomness. This is incredibly exciting. And we've omitted events in our lottery contract to use in the off-chain event logging of Ethereum. I know we're getting antsy to actually run this on a real chain. So let's go ahead and do our last bit here. We'll create our integration test, which we will run on an actual chain. And then if we wanted to, we go ahead and try our deploy lottery function on a real chain as well. All right, so let's do our integration test here. This is where we're going to actually test on a real live chain. We're going to use Ringpy because that's the network that we've been using this whole time, which is great. Now, I'm being a little bit liberal in the way that we're doing our tests here. And we're just going to do one test for this integration test, but keep in mind, you're going to want to test every piece of your code. So let's just create a test called def test can pick winner. Now, this is going to be the opposite of our unit tests. Our unit tests are only going to be on our local blockchains, right? We're going to skip if it's not on our local blockchains. We're going to do the opposite of this one. So we can even just copy this, or we can type it out. We'll say if our network show active is in those local blockchain environments, then we're going to do pytest.skip. Of course, since we're grabbing these pieces, we're going to do from brownie import network. We're going to import pytest. And we're going to do from scripts dot helpful scripts import local blockchain environments. We're going to deploy our lottery. So lottery equals deploy lottery, which we're just going to grab from scripts dot deploy lottery import deploy lottery. We'll do account equals get account. And of course, we're going to grab that from our helpful scripts as well. So we'll do lottery. Let's start lottery. This will be from account. We'll do lottery.enter. We'll say this will be from account. We'll do some value, which is going to be lottery.get entrance fee. And if we run into an issue here, sometimes, again, we can do lottery.get entrance fee plus like 100 or 1,000 or something like that. This is going to be barely anyway, but for now, let's keep it like this. Then let's just copy this line. Run it again. We'll have 2 people enter the lottery. Of course, it's going to be us both times. And great. Now we're going to want to actually end the lottery. So first we're going to want to fund it. So let's import that funding script. So we'll get fund with link, or that function. So we'll call our fund with link function on our lottery contract here. And then we'll go ahead and end the lottery. So we'll say lottery dot end lottery. We have to do this from our main account. We have to do this from the admin account. Now, this is where it's going to be a little bit different from our integration tests, or from our unit tests. In our unit tests, we pretended that we were the VRF coordinator, and we called the callback with randomness. We pretended that we were a Chainlink node. Here, we're not a Chainlink node because we're on an actual network, so we're actually just going to wait for that Chainlink node to respond. So for simplicity, we'll just do time.sleep, and we'll wait like a minute for it to respond. Of course, since we're using time, we're going to want to import time right at the top. And then, since account was the only one to actually be in this, we'll do assert lottery dot recent winner equals account. And we'll also assert lottery.balance equals 0. All right, great. So we have an integration test that we can run, which is going to run through pretty much the vast majority of our functionality here. So we can go ahead and test this with Brownie test. We'll be a little bit verbose here. We'll say -k, test can pick winner. And then, of course, we'll do -- network rink B. Now, before we run this, per usual, we got to make sure, do we have any testnet rink B Ethereum? We do. Great. Do we have any testnet Chainlink? We do. Perfect. Do we have a .env? We do. It's got all of our pieces. Let's check our Brownie config. .env. Awesome. And again, if you don't want to use the .env, you can use that other method that we showed you guys, how to encrypt with a password that you can absolutely use. Oops, and before we run this, let's set this to start lottery, because that's the actual function here. And we'll also need to be lottery.balance with parentheses here. Sorry about that. And now we can run Brownie test -k, test can pick winner, -- network rink B. We'll also add this -s flag, which will print out whatever Brownie's going to be printing out. It'll make everything a little bit more verbose here. And if you want to, you absolutely should, because this is something that we'll have to do at some point anyways. However, if for this tutorial you want to skip it, go ahead, because we're actually going to run through this whole process of deploying and waiting again anyways. So now that we've added all of our tests, what we can do is run our entire test suite. So we'll do Brownie test. And this is going to run through all of our development tests here. You'll see it'll go really quickly. And you see how much faster it is for us to run our tests on a local chain as opposed to doing everything on a testnet. So it's going to make your life way easier. And we have everything passed here. So we know that our contract code is doing approximately what we want it to do. So it's time for the moment of truth. Let's deploy this to an actual testnet. So we have our deploy lottery script, which oftentimes I'll have it be just this deploy lottery bit, and then I'll have some other scripts for these other pieces, or maybe I'll do it in the Brownie console. But just to demonstrate everything end to end, we'll have deploy lottery, start lottery, enter lottery, and end lottery all in this one script so that we can see everything end to end and see what it looks like on Etherscan. So let's go ahead and run this script on a RinkB network, and then we'll go jump onto Etherscan and see everything. So let's do it. Brownie, run scripts, deploy lottery, network RinkB. So first, we went ahead and we deployed our lottery. We got our addresses with our get contract method. We got our fee, we got our key hash, we got our published source and everything here. Then we went ahead and verified it because of this published source. So if we grab this address, lottery deployed it here, we jump over to RinkB Etherscan, we paste this address in here, we'll see this contract with the little check mark is verified. And again, we'll go to the read contract. We can see all the public variables and all the public functions. We can go to write contract and we'll see all the transacting functions that we can interact with. After we get verified and things get deployed, we went ahead and called our start lottery function to actually start the lottery. We got our little print line saying the lottery started. Then we entered the lottery. We then funded the contract with Link so that we could get our random winner back. And then right now our end lottery is confirmed. And we're just waiting this 60 seconds, right? Because we did this time.sleep. And if we sit on this contract, if we go to transactions and we refresh, we can actually see some of these different method calls over here. We can see we did a contract creation, we started the lottery, we entered the lottery, and then we recently ended the lottery. And you'll see in our script here, it says 0x blah, blah, blah is the new winner, which is perfect, right? That means that the Chainlink node actually responded. We can actually verify that by looking in the contract. We'll go to read contract. We can go to the recent winner and see somebody did indeed recently win. We can also go to events and we can see some of the events that we created. We can see this first event right here is this requested randomness event. This is the event that we called. And we have this end lottery here. We can also see an ownership transferred function that got called. This was called when we actually deployed this in the first place. Now, a little bit more on these events, aka these logs, right? So topic 0, this hash represents this entire event right here. And this bit is going to be our topic 1, our first topic, which represents that request ID. So this is going to be the request ID. Awesome. We have successfully created a working smart contract lottery with true provable randomness. This is absolutely insane, incredible job here. Now, one additional piece that I want to talk about before we jump off here is, again, in our testing. A file that you're often going to see is what's called conftest.py. Python automatically knows to look for this conftest file and will grab different functions from it. We can also add external plugins, fixtures, hooks, testing root path. It adds a lot of really fantastic features and is a common thing that you'll see. We skipped over in here for simplicity, but in future projects, you'll probably see this conftest file, which has a lot of really nice testing configuration pieces in it. Now, that was a lot of stuff to code, and quite frankly, I don't think any of us want to have to do that every single time, have to code everything from scratch. Now, you can absolutely git clone all of these repositories right from their GitHub, but there's actually an even easier way for us to start with a blank project here, and this is with Brownie Mixes. So if we Google Brownie Mixes GitHub, we'll get this Mixes organization, which just has a ton of boilerplate code for us to go ahead, get started, and start developing. The one we're going to be working with is this Chainlink Mix piece, which is forked from this official one here. This gives us some wonderful contracts, some tests, a Brownie config, and really everything that we need to do to get started. So if you have Brownie installed, we can just bake this mix. So we'll do Brownie, bake, Chainlink Mix, and in our new empty directory here, we'll get this new Chainlink folder with everything inside of it. So then we can cd the Chainlink, and we can see it has all of these pieces in here already. In the contracts, we have a whole bunch of different samples of working with the VRF, working with the price feed, working with this thing called keepers to automate our smart contracts, and making API calls and delivering any API call that we want to the blockchain. It also has a Brownie config, which already has a number of wonderful pieces in each one of these networks so that we don't have to go copy paste and add it in here. It's even got support for testnets like Avalanche, Polygon, Binance, and more. It has a number of really powerful tests, including testing some price feeds. It has a whole bunch of deployment scripts, some mocking scripts, some helpful scripts, and really everything that we need to get started and get going. For starters, we could run Brownie test. And it's going to compile everything. And then on a development chain, run all these unit tests. And if we wanted to test this on a real testnet, we could do Brownie test -- network ringp, or any network that we wanted. If you're looking for a good starter place that has a lot of really powerful smart contracts for you to get started, I highly recommend using this mix as a boilerplate starting point for any of your contracts or any of your projects here. Now we are cooking. So we've learned a ton of the fundamentals of working with Brownie and working with smart contracts. Now that we have kind of all the building blocks, though, we can actually code a lot of these much faster and much more efficiently than before. One of the things that we've seen over and over and over again is working with tokens and the ERC20 token standard. We're going to learn how to build our own token. But before we do that, let's understand why we'd even want to do this. Now, first, let's define even what are ERC20s. So ERC20s are tokens that are deployed on a chain using what's called the ERC20 token standard. You can read more about it in the ERC20 token standard here, link in the description as well. But basically, it's a smart contract that actually represents a token. So it's a token, but it's a smart contract. It's both. It's really cool. Tether, Chainlink, UniToken, and DAI are all examples of ERC20s. Technically, Chainlink is in ERC677, as there are upgrades to the ERC20 that some tokens take that are still backwards compatible with ERC20s. And so basically, you can think of them as ERC20s with a little additional functionality. Now, why would I even care to want to make an ERC20? Well, you can do a lot of really cool stuff with it. You can make a governance token, you can secure an underlying network, you can create some type of synthetic asset, or really anything else. In any case, how do we build one of these ERC20s? How do we build one of these tokens? Well, all we have to do is build a smart contract that follows the token standard. All we have to do is build a smart contract that has these functions. It has a name function, a symbol function, decimals function, etc.